Hey everyone, and welcome back to the Print Lab Chronicles. After diving deep into choosing your first FDM 3D printer in our last video, it's time to talk about what truly brings your creations to life, the filament. Choosing the right material for your 3D prints is just as crucial as having a great printer. Get it right, and your prints will be strong, beautiful, and exactly what you envisioned. Get it wrong, and you might face frustrating failures, wasted time, and materials. So, today I'm going to guide you through the essential FDM 3D printing filaments, focusing on the ones you'll encounter most as a beginner and give you the knowledge to confidently pick the perfect material for any project. First off, what exactly is filament? Think of it as the ink for your 3D printer. It's typically a plastic material wound onto a spool that your FDM printer heats up and extrudes, layer by microscopic layer, to build your design from the ground up. Understanding its properties is key to successful printing. Let's start with the undisputed champion for beginners, PLA, or polylactic acid. If you are just getting into 3D printing, chances are your first successful prints will be with PLA. It's incredibly easy to print with, boasts minimal warping, and emits no strong odors, making it perfect for home environments. PLA is fantastic for prototyping, decorative prints like vases or figurines, and non functional parts where high strength isn't the primary concern. When printing with PLA, you will typically use lower temperatures compared to other filaments. Good bed adhesion is usually achieved with simple methods like blue painter's tape or a glue stick, and you won't need a heated enclosure. Its pros are clear: ease of use, a vast array of vibrant colors, and its derivative from renewable resources like cornstarch, making it biodegradable. However, it can be a bit brittle and has lower heat resistance, meaning parts might deform in hot environments like a car on a sunny day. A common beginner mistake is leaving PLA exposed to humidity, which can degrade its quality over time, leading to issues like stringing or brittle prints. Always store your PLA in a dry place. Moving up a notch in durability, we have PETG or PETG, polyethylene terephthalate glycol. This material is often considered the best of both worlds, offering more strength and flexibility than PLA, along with excellent layer adhesion. It's also known for its food safe options, making it suitable for functional parts, mechanical components, outdoor prints, or anything that needs a bit more resilience than PLA can offer. Printing with PETG requires slightly higher temperatures than PLA, and you might notice it can be a bit stringy. This is where fine tuning your printer's retraction settings becomes crucial. Proper retraction pulls the filament back slightly when the print head moves, preventing those pesky strings. While not strictly necessary, PETG benefits greatly from a heated print bed for optimal adhesion. Compared to PLA, PETG offers superior durability and better temperature resistance, but it's generally a bit trickier to print than PLA, though still much easier than our next material, ABS. Then there is ABS or acrylonitrile butadiene styrene, the classic workhorse of 3D printing. ABS is incredibly strong, impact resistant, and boasts excellent heat resistance, making it ideal for mechanical parts electronic enclosures, automotive components, or any item that will face higher temperatures or significant stress. However, ABS comes with its own set of challenges. It requires a heated print bed and often an enclosed printer to prevent warping and cracking, as it's prone to shrinking as it cools. Another important consideration is the fumes it emits during printing, which can be quite strong. Proper ventilation is essential when working with ABS. While its strength is a huge advantage, the difficulty in printing and the ventilation requirements often steer beginners towards PLA or PETG first. For outdoor applications, you might also consider ASA, which shares many of ABS's properties but offers better UV resistance, preventing degradation from sunlight. Beyond these common three, there is a whole world of specialized filaments. Let's touch on a couple you might encounter as you advance. TPU or thermoplastic polyurethane is our go to for flexible prints. Think rubber like flexibility, perfect for phone cases, gaskets, or any part that needs to bend or absorb shock. You will print TPU slowly, and it often works best with direct drive extruders to prevent tangling. For industrial level strength and low friction, we look to nylon. This material is incredibly durable and wear resistant, making it ideal for functional prototypes and gears. But be warned, nylon is highly hygroscopic, meaning it loves to absorb moisture from the air. It requires very dry storage and often benefits from a heated chamber during printing to achieve the best results. If your nylon sounds like popcorn when printing, it's wet. Finally, we have composite filaments. These are standard filaments infused with other materials like carbon fiber, glass fiber, wood, or even metal particles. They offer unique aesthetics or enhanced properties, but beware, their abrasive nature often demands a hardened steel or ruby tipped nozzle, as standard brass nozzles will wear out quickly. Now, let's take a look at different filament types and various flavors we have access to. Let's start with PLA, basic standard PLA. The most common, easy to print, wide range of opaque colors. PLA Plus, enhanced version with improved strength, toughness, and sometimes better heat resistance and less brittleness than standard PLA. Silk PLA produces prints with a glossy, smooth, almost metallic or piercelent finish, often resembling silk fabric. Matte PLA offers a non glossy, subdued finish, excellent for reducing visible layer lines and a more professional, less reflective look. Glow in the dark PLA contains phosphorescent pigments that absorb light and then glow in the dark. Available in various glow colors green, blue, etc. Wood filled PLA or wood PLA contains real wood fibers, giving prints a wood like appearance, texture, and even smell. Can often be stained or sanded. Metal filled PLA or metal PLA contains fine metal powders. For example, bronze, copper, aluminum, stainless steel. Prints have a metallic sheen and can often be post processed, sanded, polished, patinated to look more like real metal. Carbon fiber PLA or PLACF infused with chopped carbon fibers, significantly increasing stiffness, strength, and dimensional stability while reducing weight. Requires an abrasive resistant nozzle. Sparkle or glitter PLA contains glitter or sparkly particles for a shimmering effect. Transparent or translucent PLA allows light to pass through, creating clear or semi transparent prints. Color changing PLA. Thermosensitive or thermochromic changes color based on temperature. UV reactive or photochromic changes color when exposed to UV light or sunlight. Marble PLA contains small flakes or particles to mimic the look of natural marble stone. High speed PLA or PLAHS formulated for faster printing speeds with less risk of clogging or loss of quality, often optimized for newer high speed printers. Lightweight PLA, LWPLA, designed for low density prints, often used for RC planes, cosplay pops, as it can foam during printing to create lighter parts. Conductive PLA contains conductive particles, allowing for printing of low voltage circuits or touch sensitive interfaces. Scented PLA infused with scents that are released during printing. For example, coffee, chocolate, fruit. PETG, polyethylene terephthalate glycol modified. Basic or standard PETG, known for good strength, flexibility, chemical resistance, and ease of printing relative to ABS. Available in opaque and translucent colors. PETG-CF, carbon fiber PETG. PETG reinforced with carbon fibers for increased stiffness and strength, similar to PLACF. Requires an abrasive resistant nozzle. PETG ESD safe contains additives to make it electronically dissipative, suitable for printing electronic enclosures or parts that need to prevent static discharge. High flow PETG or PETG HF optimized for higher print speeds, reducing limitations for faster printers. PETG Tough, enhanced version with increased impact resistance, transparent PETG. Very popular for clear parts due to its inherent clarity and strength. ABS or acrylonitrile butadiene styrene. Basic or standard ABS. Strong, durable, and good heat resistance, but prone to warping and emits fumes. Wide range of opaque colors are available. ABS Plus or Pro ABS. Improved version with reduced warping, better layer adhesion, and sometimes less odor. High impact ABS, formulated for even greater toughness and impact absorption. Flame retardant ABS contains additives to make it self extinguishing or resistant to burning, important for certain industrial or electronic applications. Transparent ABS allows for translucent parts, though often with a slight yellow tint. Glow in the dark ABS contains phosphorescent pigments for glow effects. Conductive ABS blended with conductive carbon particles for creating electrically conductive components. Color changing ABS, similar to PLA, thermosensitive and UV reactive versions exist. ABS CF, carbon fiber ABS. ABS reinforced with carbon fibers for maximum strength and stiffness. Requires an abrasive resistant nozzle. ABS Kevlar. ABS reinforced with Kevlar fibers for extreme durability. ASA, acrylonitrile styrene acrylate. Basic or standard ASA, known for excellent UV resistance, weatherability, and similar mechanical properties to ABS, but without the yellowing or degradation in sunlight. Available in various opaque colors. ASA CF, carbon filled ASA. ASA reinforced with carbon fibers, offering enhanced strength and dimensional stability while retaining UV resistance. Requires an abrasive resistant nozzle. Glow in the dark ASA. ASA with phosphorescent additives. ASA-X or modified ASA often refers to improved formulations for better printability and specific mechanical enhancements. LWASA or lightweight ASA can form like LWPLA for lighter parts, maintaining ASA's environmental resistance. TPU or thermoplastic polyurethane. Standard TPU, the most common flexible filament, known for its elasticity, abrasion, resistance, and durability, measured by shore hardness. For example, 95A, 90A, 85A, 60A. Lower number means more flexible. High flow TPU or TPU HF, optimized for faster printing with less extrusion issues. ESD safe TPU, electrically dissipative for sensitive electronic applications. Color changing TPU, less common but exists. Multicolor and specialty aesthetic filaments, often PLA based but can apply to others. Rainbow or multicolor gradient, a single spool that transitions through multiple colors. For example, red to orange or yellow to green to blue. The color changes gradually along the length of the filament. Dual, triple, quadcolor, co-extruded. These filaments are extruded with two, three, or even four different colors side by side in a single strand. When printed, the object shows different colors depending on the viewing angle, creating a dynamic, iridescent effect, often referred to as magic or mystic filaments. Iridescent or shifting. Filaments that have a subtle color shift or shimmer developing on how light hits them, often a mix between silk and a very fine glitter. Fluorescent UV reactive. Filaments that glow vibrantly under UV or black light but don't retain a glow in the dark. Chroma or metallic sheen. Filaments specifically designed to mimic polished metals without containing actual metal particles. Stone or ceramic filled contains fine stone or ceramic particles for a textured, matte, or often heavier print resembling natural materials. Glitter or sparkle, already mentioned under PLA, but can be found in other bases too. Other notable specialty filaments: nylon, standard nylon, strong, flexible, durable, low friction but highly hygroscopic, absorbs moisture readily. Nylon CF, carbon fiber nylon, extremely strong and stiff, very popular for industrial applications, requires abrasive resistant nozzles and dry storage. Nylon GF, glass fiber nylon. Nylon reinforced with glass fibers for improved strength and stiffness. Polycarbonate, very strong, heat resistance, tough. Can be challenging to print. PCCF, carbon fiber PC. Polycarbonate reinforced with carbon fiber. PCABS, a blend combining properties of both. Polypropylene, PP, lightweight, chemical resistant, flexible, good layer adhesion, difficult to print due to warping. PPGF, glass fiber PP reinforced with glass fibers. PPCF, carbon fiber PP reinforced with carbon fibers. HIPS, high impact polystyrene, often used as a solution support material, dissolves in limonene for ABS, but can also be printed as a standalone material with properties similar to ABS but less warping. PVA, polyvinyl alcohol, water soluble support material, primarily used with dual extruder printers, dissolves completely in water. PVA, polyvinyl acetate, a type of water soluble support. PEEK, polyether ketone, and PEI, polyethylamide, high performance engineering plastics for extreme applications requiring high temperatures, chemical resistance, and strength. Require specialized high temperature printers. ESD, electrostatic discharge safe. Various materials, PLA, PETG, ABS, PC, etc., treated to be static dissipative, crucial for printing parts for electronics or sensitive environments. Magnetic filaments contains powdered iron, allowing prints to be attracted by magnets. Conductive filaments, already mentioned for PLA and ABS, for basic electronic circuits. Graphene infused filaments for enhanced conductivity or other properties. Biodegradable or eco friendly alternatives. While PLA is biodegradable, some companies offer other brands marketed for their environmental footprint. Food safe filaments. While many plastics are inherently food safe, the printing process itself can introduce contaminants. Some manufacturers specifically certify their filaments for food contact, though. Always research best practices for 3D printed food contact items. Medical grade filaments designed for specific medical applications, often biocompatible and sterilizable. Recycled filaments offering a more sustainable option. Now, beyond the filament type itself, there are a few essential considerations for any beginner. First, proper filament storage. Humidity is the enemy of most filaments, especially hygroscopic ones like nylon or PVA, polyvinyl alcohol, often used for dissolvable supports. Keeping your filaments dry, whether in a dedicated dry box or vacuum sealed bags, prevents common print issues like stringing, blobbing, and weak layer adhesion. You literally hear a difference if your filament is wet, a popping sound as it prints, indicating moisture boiling off. Next, let's talk about nozzle types. For PLA, PETG, and ABS, a standard brass nozzle is perfectly fine. But as you venture into those exciting composite filaments like carbon fiber or even glow in the dark, their abrasive particles will quickly wear down brass. That's when you will need to upgrade to hardened steel or even ruby tipped nozzles, which are designed to withstand the extra wear and tear. Remember that optimal print settings like temperature and speed will vary not just by filament type but also by your specific printer model. Don't be afraid to experiment and fine tune your settings. Finally, when purchasing filaments, you will find a wide range of prices. While cost shouldn't be your only driver, rest assured that even more affordable filaments have significantly improved in quality, and high quality options have become more accessible. It's about finding a balance between budget, print quality, and reliability for your needs. So, there you have it, a comprehensive dive into the world of FDM 3D printing filaments. From the beginner friendly PLA to the tough ABS, flexible TPU, and specialized composites. Each material offers unique properties for your creative journey. The key is to understand what each filament is best for and how to handle it for the best results. Don't be afraid to experiment. Each filament has its own personality, and learning to master them is a rewarding part of the 3D printing experience. Thanks for watching. If you enjoyed this guide, like, subscribe, and leave a comment below. I would love to hear about your favorite filaments or any tricky material challenges you have overcome. I'm also adding and specifying a couple of affiliate links in the description. It doesn't charge you anything, but helps grow this channel by providing a little bit of commission on sales at no cost to you. New videos every week, learning, unboxing, testing, failing, fixing, and everything in between.